Good afternoon and welcome to Design Master Training. My name is David Robison. Today we're going to take a look at some features in the new one-line diagram component that we have in our software. If you're attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497. And our email address is support@designmaster.biz. For questions, you can ask them. You can also put them in the chat box. Questions can go there. So today I want to look at some of the features we have for making it easier to get the drafting on your one-line diagrams working. So I've got a Revit model here. I'm going to go ahead and put in some of the devices that we've already got in our model. So we'll put our transformer in, and you can use the insert link to put in devices that already exist in your model. So we've got a transformer. We're going to put in our MDP. We'll use our switchboard. For the switchboards, we have built into our families a number of these grips. You can use these to modify the appearance. So this is just a standard Revit family. These are standard Revit functionality, but we do have these built in so that you can adjust this appearance how you want it to. So you can get if you need something bigger or smaller, you can adjust it. You can locate the bus bar where you need it to be. So these are all built in here to make it possible for you to get the layout of your switchboard looking how you want it to look. Get the size right so you can get all your documentation and everything else in there. You'll notice that as I move it around, this label gets pulled around. That's a function of how Revit deals with where labels are. So just be aware that if you have labels in there and you start moving it around, Revit is helpfully going to move your labels for you. So you might need to come back in here as a second step and get your labels back where they belong. When you move things around, the feeders are not going to automatically update. So your feeders will get disconnected from where your things are. The simplest way to get them back is to use the feeder reset command. If you run this command, it will just redraw the feeder automatically for you, so it'll do its best guess as the routing of it. So if I select this feeder, it does prompt you for where you want that feeder to start. You can select a specific spot, or you can just press escape and it'll use the default location. So if I click a point here, it's going to draw it from there to where it should connect. If I run it again, and this time if I just press escape, it'll find a spot for us on that transformer and make the connection. Again, as you're moving things around, the feeder reset is very helpful for getting the feeders back to looking right. If the feeder that comes in isn't how you want it, because it's doing its best, but it's not always going to know the other stuff that's there, you might need to redraw it. The feeder draw command allows you to route it manually. So we could use the feeder draw and say we want to take this middle point, and then maybe we're just going to come off at an angle and do our connection. So the feeder draw is specifically there for when the feeder that we're putting in automatically isn't what you want, and you want to just real quickly recreate it. You can use feeder draw for that purpose. The other options you have for adjusting your feeder are to use these other commands. You can redraw a single segment. So if a segment of that feeder came in and you didn't like how it was looking, you can use the segment draw. You can select that one segment and redraw just that piece. So if we wanted to go back to something like that, we could put it in and it'll redraw just that specific portion. You can also move the feeders around. So say this wasn't in a good spot and you want to actually have it up here. When you do that, it doesn't all move because it's actually made up of separate families, so it's not a connected line or anything. So when you move that piece, it kind of gets connected. We have the segment trim and extend, where you can select the portions of the segment, and then you select which corner, in this side or this side, and it'll trim it for you. I did the same thing with these two segments as well. That command actually keeps going until you press escape, so you can continually trim your segments until you have it looking right. So the layout of the feeders, what we put in, we do our best to get something in that looks nice. but then we've got those commands to help you with the drafting to get them to look how you want them to look. Partly because we're not just using detail lines, so they are these families, and so they're a little bit more cumbersome to work with than a standard line in Revit. So those commands are helpful for getting them to look right. When you use the insert link or the insert create, we pull in the definition and the appearance of that panel from the families that you have set up in your customization. Once they're in, you might, for a specific project, for a specific purpose, want to adjust what something looks like. Say we want to take this voltage and we actually want to have it here outside of the panel. To then reuse that is where we have the copy commands available. So rather than inserting a new item, it's going to come in with the same label location. If we want to reuse this arrangement here, we can use the copy link. So I run the copy link, select that. It wants to know which piece of equipment we're going to use for the copy. I'm going to choose that P panel, give it a location. It will copy that, and it will copy that label location. In addition to copying all of the information from the panel, it also is going to copy the feeder arrangement. So if I get rid of this, and in Revit, in our software, if you just use standard Revit, just delete, it will remove it from the one line. It's not removing it from the model. So now we're just saying we're going to redraw that. Say we want to pull this label down here, and it's wider than we want it to be, so we're going to make it a little bit smaller. So we want our feeders and our panels to look like this. Again, we can use copy link, and when we do that, it's going to copy both the arrangement of the panel and the arrangement of the feeder as well. So you put one panel in, get the feeder looking right, you get the panel looking right, and then you can use the copy command to get other ones coming in that look the same. You also can use Revit itself to make the copy. With our copy link, you'll see that it's coming in, and the insertion point is the base insertion point of that family, which sometimes works and sometimes is not what you want to use as the base point. You can use the standard Revit copy command, and now you can actually specify a base point. So say we wanted to actually use this point here as the base point, or we wanted to have it offset the same distance from here to the next one, we could choose that, and then you can choose your other base point. So now you can use the Revit base points to make the copy. And when we do that, it makes the copy, but this item here is now actually no longer linked to that E panel. If you run the calculate, you'll see that it's going to come in with a bunch of question marks. And actually, when you run the calculate, it'll say, hey, this thing, you copied it, and it's no longer linked to anything in the model. And then it'll give you an option, do you want to delete it? So, because sometimes you'll make a copy and you don't want it there anymore because that thing doesn't exist. You can delete it. You can also leave it on the one line, which is what we're going to do in this case. So now we've got this item here that's a copy, and it's not linked to anything. And then once you've done the copy, you use the change link command, select that piece of equipment there, and then we'll select P, and that will now link it to P. We will try that one more time and see if it works or not. There, so now the link worked. So that's how the change link command works. So it allows you copy it using Revit, and then you use change link to get the right device in. We also have the ability to match annotation tags between pieces of equipment. So if you have a bunch of these in and then you realize you do actually want to adjust where some of these tags are, say I want to pull this back up here, and again I'm going to pull this label out here, and then you want to reuse this layout for this panel without actually having to redraw that panel, you can run the match labels, and it'll match just the labels. And that gets the annotation tags in the same locations. So once you do a little work, get one that's looking right, and then you can use match labels to reuse that for other ones to make them look the same. When you select this equipment, you'll see that we've got over here a bunch of shared parameters. This is where we output all of the information that the software is calculating. And so we put it all here so that you can label with it, but we don't, by default, include all of those labels because everyone labels their one lines a little differently, and every one line requires slightly different labeling. With the software, we ship a number of tag symbols. So if you run the insert and load family command, and you go to your customization folder, there's going to be a number of device tags. But if you scroll down, all of these DME tag families are our tags. So these are additional tags that you can use that are built into the software. So we kind of provide these as a convenience to you. You can also create your own. So say we want to label the, well, let's put in one of those tags, and then we'll create our own. So to put in one of those additional tags, you use the annotate command, and we'll tag by category. We'll select this item here, and it puts in the new annotation, and then you select the tag that you want to use. So if we want to put in voltage drop, do I have a voltage drop? I do have a voltage drop. So we're going to do the voltage drop for our distribution equipment. So there's the voltage drop to this piece of equipment. Now it's just outputting that as decimal value, which is probably not how you actually want to document it. You might want to have a percentage or something else of that nature in there. So let's go ahead and clean that up. So if I select this piece of equipment again, we can see all of the labels. Let's find the parameter that we actually want to use. So we have these DMET voltage drop values, and those nicely format that. This must be using one of our numeric ones. Yeah, so it's using this value here, the numeric voltage drop, which is just going to output the parameter as a number, and then use your built-in settings in Revit to get the formatting on that label. If you want to use our built-in formatting, you can use the DMET. So we'll go ahead and swap in the DMET value there. So we'll edit this family, and it's just a single tag here, and we're going to add our label to it. The first thing you need to do is link our shared parameter file to Revit, and that is under Manage Shared Parameters. And you need to choose your shared parameter file here. You can click Browse, and then you'll want to go to your Design Master folder. So if you go to Program Files, and you go to Design Master Software and Electrical RT, there would be a number of shared parameter files there. I don't have them on this computer, but that's where we store them. In your default install folder, Program Files, Design Master Software, Electrical RT. And you've got your shared parameter files there. And you can select the one that you want to use. And then you'll have all of our shared parameters available to you. When you're done, you can switch it back to your company's shared parameter file, which is probably what you want to do. But this way you can use ours for a moment. And then we can select this tag here, go to the label, and click Edit. Over here are the parameters that we can include in the label. So we actually have to load one from that parameter file. So we can add a parameter, select it. We want to do a voltage drop. DMET voltage drop. We'll do the total voltage drop to that panel. Select that. Click OK. Now it's here and available. We can insert that one. Get rid of this other one. And we can click OK. And now we have that new parameter in here. I will load that into the project. We'll override it. And so now it's that parameter, that tag is using that new parameter for the labeling. And then once it's in there, you can again use standard Revit to get this label looking how you want, with or without a leader, however. If we wanted to put some additional labeling on there, because right now it's just a number without any sort of indication as to what it is, we can come back in here, go into the label, add the prefix voltage drop. So if we put a space after it, it'll actually put a space between the prefix and the value. Load that into the project, and now we've got an annotation with the label and then the value in it. So that's what I wanted to show you today about customizing and modifying and getting the drafting right on your one-line diagrams. I just want to do a short little lesson on that. Are there any questions related to one-line diagrams or anything else in the software? So there's a question. Want to see some of the nuances of custom feeder schedules and how to display them, and tag options as well. So for the tag options, are you looking at the feeder tags here, or are you asking about something else? So you're talking about the feeder tags. Perfect. Yeah, I can talk about these feeder tags and how those work and how you can use them. So we have the schedule insert, which will insert a schedule of all of the feeder tags that are currently being used in the drafting view that we're on. So we'll put that on there, and then we'll talk about these a little bit. We put in this feeder schedule here. It's got each of the families with the tags in it. So this is the ID, the identifier for that feeder. And then over here on the right, you have the actual construction of wires that is associated with that feeder ID. So we have a fair amount of customization built into this because we discovered that this is one place that everyone does things a little bit differently. So we tried to make sure that we could handle what kind of system, whatever system you want to use, as best as we can. Let's go with the simplest thing first, and that's just the appearance of the tags. So right now we've got these little hexagons. If we go to customization and we go to project feeder ID schedule, there's a lot going on here. We're going to ignore most of this for a moment. If we go to this group, we've only got one group, but it's the general group, and we edit it. We can now, these are all the groups that we have available. Each group can have a separate ID graphic. So right now, we're using the hexagon. We could change that, and instead of using the hexagon, we could, for example, use our oval graphic instead. So I'll just make that one change. Nothing is going to change until we run the calculate. But when we run the calculate, we'll see that that option has changed, and it'll update the graphics. So now we've got an oval graphic there. There are some companies that like to use different graphics for different types of wire. So maybe you use an oval for copper and a hexagon for aluminum. I'm going to go ahead and run panel edit. Select this panel here. We're going to change this to aluminum wire. Okay, so that updated the ID there. And if I run the schedule insert again, it'll update it over here. We can actually create a second group that would have this ID in it so that it would actually get a different graphic because to denote that it's aluminum versus that copper. So if we go back to project schedule options, go to our groups, we'll make a new one. So we'll call this one copper and this one aluminum. And we'll go to the copper and we'll take this one here, which is using our copper wiring. We are going to move it to the aluminum group. So now this group has just this one ID in it. Moving on from that, you have the actual IDs themselves. So we are generating those IDs for you using a format that we have. You can also, so there's two different formats. We have the short and the long. The short is what you're seeing here, where for 100 amp ampacity feeder, we're just using 100 as the ID. We also have an option for a long ID. So if you go to your options and you go to format, you can go from short to long. And when you change your format, it's going to prompt you if you want to clear your IDs because all your IDs are going to be using that old format. So we're going to clear all our feeder IDs. And now when we run our calculate, it'll see that there's IDs that it'll know to recreate the IDs. So there's a long format. That's what it should look like, where it has a /3 saying it's a 3-wire, N saying it's a neutral, and J saying it's using a service jumper for the grounding sizing. So the long has a little bit more information in it. It's longer, obviously, so it's a question of how much information you want to try and cram into that ID versus using something a little more terse and then pointing them over to the schedule. So that controls the automatic creation, and you might not like what we're doing for automatic creation. So you can also, under project options, we have the option here to automatically create the feeder IDs. You can change that from yes to no. And now every time it needs a new ID, it's going to prompt you for what that ID should be. So if I go modify this panel here, and change my bus size. That's going to give me a new feeder size. It's going to say, hey, oh, I need a new ID for the one-line diagram. What do you want this ID to be? Here's the wire callout that exists. Here's the ampacity of that wire. What ID do you want to use, and what group do you want to put it in? So maybe you want to call this a 600 AL, however you're labeling them. So you put in your ID here, and then the software knows that, okay, that's what it's going to use. So this gives you the chance to just create them. And so it's a little bit tedious, but you could slowly build out all your IDs using some sort of custom format if you don't like the ones that we have. And now it's going to use that format there. Also under project options, we have two more options here. Export feeder IDs to master schedule when possible, and import when possible. What this does is when you create a new ID like we just did, it also puts it in a master schedule. And then on future projects, if it sees that ID, it'll see that it already exists using the import and pull it into your project. The idea here is that if you do have a formatting system that's different from ours, you can manually create all those. And yes, it's a little bit of work ahead of time, but then on future projects, it's going to be using the same ID, and that way your IDs are consistent across all of your projects. And those IDs are accessible both in the project, which we've been looking at, and then also in the master schedule. So this here is why it kept pulling in the wrong values, because I have it set to pull in values from the master. So it kept seeing that, oh, I've already got these values defined in my master schedule, so it's pulling them in dutifully for us. That's why it wasn't using the different format that I was asking it to. So if I go to my project options and say, do not import them from the master, and I'm going to have it automatically create them all. And then if we go to the project, get rid of those. Now, if I run my calculate, it should recreate everything with the long format. So there's a better example of the long format. These are all fairly similar with 3 wires and a neutral, but if there was no neutral, the end would be left off. It was a single pole or a 2-pole breaker. It would have a 1 or a 2 there. You can also change the graphics on a per device basis. So if you want to, you can use modify graphic. You can select this, replace the ID graphic, and for that one figure, you could use a rectangle, for example. So you can swap them in on an individual basis as well. And then these feeder IDs are a family. So they're, it's this little piece here, and you can move it around using our various feeder commands. So if I draw this feeder, and let's say we're coming from over here, it put the graphic here by default. If you want it on a different segment, use the graphic move command, and you can say, okay, I want to take this graphic and I want to swap it up to this one. And then you could have that ID there. And so that's the way that you can use to get your graphics to different segments on the feeder themselves. This schedule here always shows the IDs that are on the drafting view. So it's not going to show everything that is in this schedule, because this will fill up with lots of different IDs, and they're not always necessarily being used. So you don't want a feeder schedule that's listing everything that's defined. We're listing just the ones that are actually being used. We tried to do a feeder schedule using Revit's scheduling features. And while Revit's scheduling features are really, really good, this is one case where it actually can't do what electrical engineers need it to do, because the feeder IDs need to include feeders to panels, which are generally defined as electrical equipment, and then also needs to define feeders to large pieces of mechanical equipment and motors. And those are sometimes electrical equipment, sometimes they're electrical fixtures, sometimes they're other things. So you can't mash all that together in a single schedule. So we were not able to use Revit's scheduling feature to get it to work out. So that's why we had to build our own, basically, little schedule drawing over here to get the schedule. I did have some questions that were sent to me ahead of time over email. I'll go ahead and answer those. The first question is, how does our software interact with Revit for drawing tick marks? The answer to that is that we actually let Revit handle the drafting of the tick marks, and that's typically on the plan views where you're looking at those. So those are on your home runs. So we let Revit draw the tick marks, and then our software just does the sizing of everything. However Revit tick marks work, that's what you do for your tick marks, and then you just use our software for sizing them. For your labeling, you'll want to use the Design Master shared parameters. So if we select this wire here, you'll see that Revit has a wire size. And for whatever reason, it thinks these should be number 10 wires, and it's not letting you change it, and that's why you have our software instead. And down here is the Design Master wire size. So we're calling these number 12 wires. So you would want to create an annotation with our wire sizes rather than Revit's to label this. And as always, if you want to change it, you don't come in here and just start typing in values. You need to actually run the circuit edit. I select this and run circuit edit. It'll select that circuit for me automatically and change the wire there. So if that actually does need to be number 10 wire, you would change that value here if you want to use aluminum wire. And then this is updated to that number 10 aluminum. There's another question, can we assign custom feeder sizes? Yes, you can, and there are a number of different ways you can do feeder sizes depending on how custom you want it to be. So I'll run panel edit. If I select a panel, you can here choose a specific feeder size. So this is a 100 amp panel. By default, you're going to get a 100 amp feeder. If you just want to upsize it, you can select the conductor and you can assign it a different size feeder. So we could say, okay, let's use a 125 amp feeder. It's going to give us 1/0 wire. So that'll give us a larger size for voltage drop or whatever purpose. This list of options is in the wire ampacities. So if you want, let's say, a 100 amp feeder that's sized slightly differently, you can come in here and to customization to wire ampacities. And here we have all of the different choices for your sizes. So we could come here and we could make a new 100 amp feeder. Not that anyone would do this. Say we wanted to do 2 runs of number 6 wire, basically, create 2 50 amp. 2 50 amp runs, we'll do 2, and then the 50 amp is going to be a number 6 wire. You do need to set the impedance. This is the X and the R value. This is for a single run of the wire, and then we'll do the calculation if there's parallel runs. So I can just pull these from the 50 here. We've set the breaker ampacity. We need to make sure to set the wire ampacity. That is for a single run of wire. So for a single run, that's going to be 55 amps, and then the temperature rating of the conductor that you're assuming that's being used here. Once you've set all that up, run panel edit, go back to our 100 amp panel. We now have that new option for that 100 amp run of 2 runs. So that's an additional option. So that's how you can create a new option that you can select. And we do have a final option, and that is the custom option. That's where you go to the conductor here, and you can say custom. And when you select custom, you can type in whatever you want that call out to be. A lot of times people use this for bus duct, where you've got a bus duct and you don't want to label it with a feeder because it's not really being fed by a feeder. You can call it bus duct or whatever you feel is appropriate. Put in the impedance values. If you have a bus duct, you'll have to go look those up. The manufacturers usually provide that information. Also, if you're doing a configuration that we don't handle, one example would be multiple runs in a single conduit. You can do the call out here, figure out the impedances, and then you can have that done here for existing installations, or if you're trying to value engineer, sometimes they'll do multiple runs in a single conductor. So the custom allows you just complete control over what the feeder is. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.